With decimals, we're really going to focus on just rounding correctly. We'll do a little math with them, but we're going to go ahead and rely on the calculator a bit there. So in terms of place value names, so with decimals, what we're going to be seeing is this decimal place come through. Even if you have a whole number, so let's say we had the number 124, something like that, even though a decimal isn't drawn there, there technically is one. It's just right there at the end of it. So with that, values that are to the left of our decimal place, we have the ones, tens, hundreds, thousands, 10,000s, 100,000s, so on and so forth. We could just keep going and going. Then the idea is that when we start placing values on the right-hand side, those are coming from fractions, and these fractions are in increments of tens. So we have tenths, hundredths, thousandths, 10,000ths, and 100,000ths, and that could continue on to forever too. So like, let's say we had the number, I'm just not going to have anything in the ones place. Let's say I have 0.7. So this is the same thing as 7 tenths, which if I wrote that as a fraction, 7 tenths is how that would look. So it's less than a value of 1, so that's where we have our ones place, but this is a fraction of tenths. Then we have hundredths, sorry, this is hard to say through a microphone. So hundredths, let's say I had 0.61. So this would be read as 61 hundredths, which would be written as 61 out of 100. So these decimal values do relate to fractions and a fraction that's less than 1. So that's what's coming through in these places out here. So let's talk about rounding. Rounding is when we choose a place to kind of stop our value at. So let's look at rounding this number. So 6,473. And I want to round to the hundreds place, which is happening right there. So I have ones, tens, hundreds. So what I want to do is have everything following this number turn into zeros. But to do that, we need to think about, do we need to adjust this 4, meaning do we round it up, or does it stay as is? Now, to determine whether or not we round up or down is we look at the number next to it. So something I like to do is imagine this line here. I have this line here, and I'm rounding that 4. And to determine how I round that 4, I'm looking at the value on the other side, in this case 7. So that number that's to the right-hand side, so if we have this line and then some number there, if that number is 5, 6, 7, 8, or 9, we round up. So what that will look like is I'll have 6, the 4 is rounding up, so that bumps up to a 5, and then everything else turns into zeros. Now, if this had been, let's say this was 6443, let me just adjust it a little bit. And I was doing the same thing of I want to round that 4. So with that, I need to look to the number that's to the right of it. Now, this number is not 5, 6, 7, 8, or 9. So if you see a 0, 1, 2, 3, or 4, we round down. And that can even be a little misleading. It's more that we keep the value that we have. So with that, I would have 6. And then because that value to the right is a 4, we keep our value 4 and everything else turns into zeros. Let's try this with this next case. So this is the same number, 6473, but now I'm rounding to the tens place. So what I'm going to do is have my number stop there and round everything else, or make everything else zeros. And then because that's a 3 right there, we're going to round down. So what that means is I will have 6,400, and then that 7 stays the same, and then that 3 turns into a 0. So, same idea with decimals. So we have this 0.7049, and I want to round to the hundredths place. So we have tenths, hundredths. So I want to round to right there, and I need to look to the right to see, are we rounding up or down? So because that's a 4, we're going to round down. So what that means is that we'll have a 0.7, and then the 0 just stays the same as 0, and we leave it like that. You could write 0, 0 at the end there. You could even just write this as 0.7. That's correct too. They said specifically the hundredths place, then we want to show at least to that spot typically, but that should all work. All right, with this one, rounding to the thousandths place. So thousandths place is right there at 4. So I want to end my number there, but I need to look to the right, which a 9 tells me to round up. So we'll have 0.70, 4 rounds up to a 5. We'd have a 0 where the 9 is, but really you could just end the number there. So this is a difference between these kind of whole number roundings and the decimal places. With the decimal places, you don't need to fill in every single 0 for the number that follows. However, for whole numbers, you absolutely do. Because if I just wrote that as 64, that's a very different number from 6,400. Whereas with our decimals there, so I don't want to do that, with our decimals, writing this as 0.050 is the same exact thing. It's just that 0 isn't adding much information at the end there, so we can just write as 0.705. All right, calculations with decimals. In the textbook, you could read through how to do these by hand if you want to. Really, for our class, I'm going to focus on we'll use our calculator for these. Let's round each solution to the hundredths place, which is a typical rounding technique. This gives us 2 decimal places of accuracy, which tends to be pretty good. So if you see rounding to the hundredths place, that's the same thing as showing 2 decimal places. All right, so let's look at using the calculators with these. So 3.75 plus 12.8. So what I'm going to do is just type that in. And we get a 16.55. Rounding that to 2 decimal places, it's actually already done for us. So that's just going to be 16.55. For subtraction, same idea. I'm just going to go ahead and type it in. 46.57 minus 38.29, 8.28. I'm just going to copy that down. All right, multiplication, 13.5 times 2.9, and rounding to 2 decimal places, which is already done for us, so 39.15. And the last one is division, so 97.4 divided by 0.4, so a 243.5. So with those calculation ones, you won't have any work to show there. We'll just use the calculator.